and we were discussed about the sensors and its classifications during the last week, and at the end we were planned to talk about the machine and all. Once we are completed the robot applications today and tomorrow, then we'll if time permits we'll see the machine. And in today's lecture we will talk about the robot applications and inspection automation, and in connection with our syllabus it was in fourth unit. And today we will talk about the robot application, in particular with the metal handling, metal transfer and machine loading and unloading operations, and it process. And for concerning today's class, I request 10 people to join with us. And it is audible from
Yes, sir, it's audible, sir.
from 31 to 40. You please unmute your mic. Like here, number 31, 33, 34, 35, 36, 37, 38, 39, 40 and 42. You please unmute your mic and please join with us till the end. Yes. My slides are visible?
Yes, sir.
My slides are? Yes, yes. Yes, this is what we are going to talk today. And in our syllabus, we have the robot application manufacturing, material transfer and machine loading, unloading, processing operation like welding, painting, and then assembly operation, inspection, automation, robots layout, multiple robots and machine interface. These are the contents which we need to discuss under robot applications. And concerning the robot application, it can be widely classified into two applications. One is industrial application, the other one is non-industrial applications. The non-industrial applications are in home sectors. We are using robots, and healthcare, survey sectors, in agriculture and farms, and research and explorations we are having robots in recent days. And in connection with the industrial applications, it can be further classified into four. Number one is material handling. Number two, processing application, assembly applications, and inspection application. And in metal handling, the metal transfer applications, machine loading and unloading, and palletizing, we are using robots. And in connection with the processing applications, for doing welding and painting, and even in scrapping painting industries also, we are using a robot. And assembly, in order to perform the assembly duct, peg in hole assembly, we are using robots in recent days. And in connection with the inspection applications, sensor based inspections can be performed today, and vision based inspection. And for further testing and all, the recent robots can be used in a successful way. And we will talk one by one. And in welding, usually there are two weldings are performed using robots. One is spot welding, the other one is arc welding. I think these contents, you please make a note with your notebook. You please make a note. I doesn't included these contents with the slides. And with you please make a note of these contents. Even after completion of the course, you please go through the video, and then you please make a note of these contents. And for spot and arc welding, we are using robots. Just a minute, I will come back. And the spot welding and arc welding are usually preferred application with the aid of robots. And in order to perform the routine task, these type of robotic arms are usually preferred. And concerning the spray painting, and in recent days we are using spray robotic instead of using the end effectors, we are using spray guns for performing the spray painting. And what was the advantage over this spray painting and all? It is the high productive quality can be obtained with the aid of um, with the aid of the robotic arms. And yeah, of course the increased productivity is possible, and less painting material usage. And it can reduce the labor cost and even saving in energy consumed. And the removal of operators from the hazardous environment, that might be very conscious information that we need to remember. As we were aware about the engineering, we need to conscious about the betterment of the human society. Therefore, in order to do the certain task with the hazardous areas like the spray painting, it may affect the lungs. And in order to remove that, this kind of robots can be performed without the human interference. And even grinding also we can use this type of robots. And in connection with the material handling, the slides I have in detail we'll talk about the material handling. And further, we are using the robots in the assembly operations. Say for example, in order to do the studs, screwing of studs and screws in the threaded holes, the robot can be used. And insertion of the shafts in particular holes, or in the engine sequence, we are using the robots. And insertion of the electronic components in the assembly lines, and assembly of the small electronic motors and plug switches and all can be performed by using robot. And like that, the robots were successfully employed for getting the work in the assembly operation. And similarly it can be used in shorting of the parts, not to short, not to group the components. We can use the robots. And that too with the special vacuum grippers are used to acquire the washer from the gravity feed mechanism. See, we are depending power sources during material handling. We need to as much as possible we need to reduce the usage of the power. Therefore we need to keep the material in such a way that it has to utilize the gravity to come by itself. By the nature of the arrangement itself, it has to come down. And by that we need to arrange the materials. See in the case of what overhead tanks, we are utilizing the gravity power. And similarly we need to place the material in such a way that it has to come down as it was based on its portion itself. And for similarly the robots are used for shorting the parts based on the dimension, based on the geometry, and it can be used to short the parts. And we were already aware about the sensors and actuators. It can be used to do the inspection of the various components, and it is employed in order to find the finished component size. And various sensors are used, and the machine visions are also used to do the inspection over the finished components. Even in some industries are employing the robots not to perform the intermediate process, whether the processes are in line with the pre-scheduled way. In that way they are using the robots now to check whether it is going smooth or not. And in recent days we are using the robots now to perform the heart surgeries. And the touch free heart surgeries are now possible with the aid of the robots. And this is what about the robot applications. And we'll talk about the material handling in detail. And material handling, the main principle that we need to remember during the material handling is that the material handling uses the right method and to provide the right amount of the right material at the right place at the right time in the right sequence, that too with the right portion in right condition, and that too with the right cost. These are things we need. There are 9 different right we need to remember during the material handling with the aid of the robotic arm. That, see, there are various methods are available to handle material. That too with we need to select the appropriate method for doing handling the material, and the amount of material has to be, see, there are 100 components required to do some necessary task, and your material handling system only disseminating 10 now 10 number of components. Then what was the deficiency? 90 might be the deficiency. Either your material handling system returns 200 component rather requiring 100. What it may consume, it may occupies the 100 component place rather, instead we are requiring only 100. It is disseminating 200, and therefore we need to be very conscious with the amount of handling the material and the right material. You are requiring the mild steel and aluminum, but your material handling system disseminating brass and bronze, that won't be right. Therefore, we need to the material handling system has to return the right material at right place. You might be in some particular place, but your material handling system disseminating material other place. You are in one particular room. Your material handling system returns the material in some other room. Means what happens? We need to pick and place from the different place. Therefore, your material handling system should return the amount at right material at the right place, and at right time. We need to get the material and right sequence during assembly and all. We need to put bolt, and then we need to put the nut and all like that. And the right sequence has to be we need to be very conscious with that right sequence and right portions. We need to prefer in order to perform this middle handling system at right conditions. Whenever you are feeding the material, it might work or works on component or one machine is working. When the material handling system returns at some particular place, at that time also it has to be perform a task in a very in a nice way. Therefore, the retention or the working condition of the components should be retained during the material handling, and it should not be very huge amount. Therefore, these 9 principles we need to remember during material handling system, and it involves the handling, storing and controlling the material. The raw material, in-process material, and finished goods are moved from one place to another in the plant. And what we are doing in the you give us. Thank you, sir. Thank you. Add value through time and place utility. The impact, space requirement, profit. See what we are doing with the in the production plant or manufacturing. We are giving the input. We are adding the addition over the raw material. In raw material, see, your raw material might be the shaft. What we are doing either phasing or turning or taper turning or whatever operation we are requiring, that we are performing. That in different way, in economics way, what they are approaching, we are adding some values to the raw material. In that way they will think, and therefore we need to the in process material and finished goods are moved from one place to another place. They add values. That is what here they add value through time and place, and they are indicating that add value through time and place utility. And impact, space requirement, profit, quality, safety and productivity is important during handling the materials. And it may consume 20% of the total production cost. And we need to remember there are 20 principles are available in order to handle the material. The first one is planning principle, system principle, material flow principle, simplification principle, gravity principle, space utilization principle, unit size principle, mechanization, automation, equipment selection, standardization, adaptation, dead weight utilization, maintenance principle, obsolescence, and control, capacity, performance, and safety principles. These are the 20 principles which we need to remember during material handling, and this we will discuss a little later. You talk now. The forum is open to you to discuss about the current affairs. Go ahead with the current affairs. Someone, please go ahead with the current affairs.
Sir, Nishant wrote an article on IPL.
Very good, Nishant. In which it was published, Sabarni?
So, Medium, the blog.
Blog.
Yes, sir.
Okay, okay, very good, very good. Very good. You can use the various blogs. Blogspot might be the familiar blog which many of us prefer. Nishant? I think today Nishant, yes, Nishant, you are available. Nishant, you talk about the content which you have disseminated in the blog. No, I think he is not a active participant today. Some other information. Someone.
Hello, sir, can you hear me?
Yes, yes. Nishant, where you went?
Sir, here only, sir. Yes, you couldn't hear me, right?
Okay. Yeah, tell me what was the article written by you?
I don't know what the marketing
Marketing?
in IPL.
Okay, yes. Go ahead with your content.
I mean, you can read it. I don't know, like, what to say right now.
I think there is an issue, net issue, Nishant.
Yes, sir.
Yes, we didn't hear you.
Uh,
Okay. Yes, yes. Now it is okay. Go ahead.
I don't know what to say. You can. It's a like 6 minute read article, so I can share the link and everyone can read it.
You critically reviewed,
Yes, sir. Like from where IPL started, how it grew,
Okay.
all that.
If your thoughts are transferred into words, but why you are hesitating to talk about your content? Already you are converted into lines,
Yes, sir.
words. Then what might be wrong with delivering the same content through oral? Okay. Anyway, you share the content. We will talk about in detail in some other class. Okay. Anyone from Mamta's state? I think
Yes, sir.
West Bengal.
Shravan.
West Bengal.
Yes, sir.
Sabarni, yeah.
Yes, sir. Yes, sir.
Sabarni already active participant. Still we are. Sabarni, what happened? What was happening in your state? What was the maximum number of legislative assembly in your state? I think 280 something. Is it right?
Yes, sir. 289 or something.
289. Okay, okay. I think the in ABB predictions again they are predicting that the Mamta will be the CM in the subsequent. Is
Yes,
my
a
right?
C. Yes, a C voter is telling TMC will come again, but then some news channels like Aaj Tak and all, like they are telling that BJP might come. It's a tough word this time. Nobody actually knows.
Okay, okay, okay. Before Mamta, who ruled West Bengal?
CPM, CPM, sir, Communist
CPM.
Party.
Okay, okay. Oh, now
Sir, like
BJP became a active participant in West Bengal, or
So like some 3 to 4 years back only they started acting like a very big opposition. Like when the TMC came into power, CPM was absolutely destroyed, and for some like maximum some 10 years and all, there was no proper opposition also. I mean, people didn't need an opposition also, like there was no such kind of problems. But like past 4 to 5 years now, BJP is acting as a strong opposition. Even in the last legislative assembly, BJP won certain seats in rural areas also, which was like quite unexpected of the people.
oh, that was the thing. The central government wants to expect that they are increasing the number of assembly people or number of
Yeah.
the people who is supporting BJP. That was in recent days. It was very huge.
Yes, sir. Like
What they
they
are
want the
doing.
states. I mean, they want the districts adjacent to all the fish tanneries and all that. That has a lot of benefits.
Sir,
Okay. Yes,
actually
Gaurav.
BJP was in means BJP was trying to make it influence in Bengal from long time back, sir. When Mamta Banerjee separated from Congress and formed its own party in Bengal, sir, that time she took
Huh.
help from BJP to strengthen her base actually, sir. From that time is
Oh,
initially BJP, she was taking help from BJP. Now after she came in power, they all know good politics. And now BJP is also trying to rise in power. That's what, sir. They all are brothers, political parties are brothers.
But the scenario in Tamil Nadu is entirely different. The BJP won't be the powered party in connection with Tamil Nadu in the past. What might be the present scenario that we can observe during May 6th? In the past, there won't be any huge impact with the BJP in connection with Tamil Nadu. Okay. What was the election date in West Bengal, Savarni or
So
Gaurav?
it's some 8 times like there'll be 8 elections. It'll start from April 5th.
April 5th. Oh, eight
Yes,
slots.
8 slots. Yes, sir. 8 slots.
Okay, good, good.
Eight
Any other?
phases.
Is any other? Okay, we'll move to middle and
Sir,
systems.
Jasprit Bumrah got married yesterday, sir.
Arun Balaji is good. Who married yesterday?
Jasprit Bumrah got married yesterday.
Cricketer. You're talking about cricketer.
Yes, bowler Jasprit Bumrah got married yesterday, sir.
Very good, very good, very
Congrats.
good. Married whom? Don't say girl. Married.
Sir, some Sanjana Ganesan, sir. She's a TV presenter.
She is a
TV
TV presenter.
presenter.
TV present. Okay, okay. I didn't have that. Okay, okay. We'll talk about the middle and system principles, and we'll again come back to current affairs when time permits. There are 20 principles we need to remember during the material handling. The first one is the planning principle. Plan all material handling and storage activities to obtain the maximum overall operating efficiency. That has to be performed not only in material handling, in all the things we need to plan in order to utilize the optimum benefits. We need to do planning. That replicates in the material handling also. And the system principles integrate as many handling activities as practical into a coordinate system of operation covering vendor, receiving, storage, production, inspection, packaging, warehousing, transportation. Like that, we need to concentrate on various things during the material handling. That might be accounted in order to have the optimum utilization. The vendors supply might be huge at some particular time, and at some particular time it may drastically down, and it has to be considered. Receiving of those materials and storage and productions, inspection, packaging, and warehousing. These things we need to remember during the middle handling. And middle four principle provide an operation sequence and equipment layout optimizing middle flow. See, already during in production subjects or industrial automation, what might be the things which your faculty may disseminated might be the optimum utilization, or the plant layout has to be in a way that the optimum way we can utilize the various operations in the material. In such a way, the plant should be arranged, the machine should be arranged the in order to complete one particular task. The flow has to be in a smooth way, and it has to short as minimal as possible. Therefore, your plant is arranged in that way. So the material flow is also should be like that. It has to be very minimal, short distance, short it has to cover, but it has to give the right material at right place at right time. And the simplification principle simplify handling by reducing, eliminating, or combining unnecessary movement. That has to be we have to be remember during metal handling. And as I detailed earlier itself, utilize the gravity to move material wherever practical, like in ore tanks, or in the liquid industries or fluid industries, like the milk industries and all. We can use the gravity as in power. That flow has to be in nature. Nature itself we can utilize the movement. Therefore any there won't be any additional power requirement now to transfer those materials. And in that way we need to arrange our materials, and the
Hello, sir. Sir, you are not audible, sir.
He's not there in the call.
Sir
Left
left
the
the
group.
meeting group.
Sir, left the group.
I guess power cut.
Chitas, now it is audible.
Yes, sir.
Ah,
Yes,
yes.
sir.
Something went wrong. Something went wrong. Yes. Yes. Slides are visible?
Yes, sir. Visible.
Yes. Yes. Ah. Then subsequently we have the unit size principle. Increase the quantity, size or weight of the unit loads or flow rate. That was headed under the unit size principle. Mechanization principles, mechanized handling operations, and automation, provide automation to include production, handling and storage functions. The equipment selection principle, in selecting handling equipments, consider all aspects of the material handling handle. And the standardization principle, standardize handling methods as well as types and size which we are going to handle. And adaptation principle, use methods and equipment that can be that can best perform a variety of tasks and application where special purpose equipment is not justified. And dead weight principle, reduce ratio of dead weight of mobile handling equipment to load carried. And utilization principles, optimal utilization of handling equipment and manpower should be essential. And the maintenance principle, the preventive maintenance, scheduled repairs has to be considered during before handling. And obsolescence over a period of over a time period, the every machine has to obsolete and replace that obsolete material things, and we need to replace with some other new system that has to be considered. Replace obsolete handling methods uh, and equipment when more efficient methods or equipment will improve the operations. Control equipment, use material handling activities to improve control of production inventory and order handling. And the capacity principle, use handling equipment to help achieve desired production capacity. And performance principle, determine effectiveness of handling performance in terms of expenses per unit handled. And safety principles, provide suitable methods and equipment for safety handling. And we need to remember this things during handling the material. Safety is very important. Efficiently we need to do the task. At low cost we need to transfer the materials, and at right time, accurately, that is the right material in the right quantity. And it has to be disseminated without any damage. And risk associated with improper handling, increase in cost of raw material and finished products, delay in production schedule, and long production cycles, waste of machine time and personal time, and increase in process inventories, damage or loss of material and employee safety liabilities. And employee frustration reduced to morale, and customer dissatisfaction. These are the things we need to remember during handling the material. And see the systematic approach we need to follow during handling the material. The first one is define the problem, why it has to perform, what in what way we have to perform, where we have to perform, and when, how and who. These we need to ask before handling material. Analyze the problem, that is observe the activity, obtain leaves, flow pattern, schedules, etc. And obtain information on existing material handling equipment. Analyze situation by 20 principles of material handling that we have discussed earlier. Can activities be combined or specified or eliminated? Some activities has to be combined, and through that we can reduce the time. Some has to be simplified, and some has to be eliminated. And identify the possible solution, that is material handlers, machine operators, supervisors, support engineers. When we are having the proper communication with these fellows, we can optimize the material handling systems, and evaluate alternatives, meet again to rate alternatives. And material handling equipment are usually classified into 5 types. One is industrial trucks, automated guided vehicles, usually called as AGVs, monorails and other rail guided vehicles, conveys, trains, and the rest. And these are usually classified in non-powered and powered. And see, the non-powered industrial trucks are some typical examples: two-wheel hand truck, the four-wheel dolly, and hand-operated low-lifted pallet trucks, and the powered trucks. It can handle the material even from 450 to 4,500 kgs. And see, when we are erecting some a new laboratory in NIT, what happened? We were handled with one 2 ton rail, and see, we are trying to lift the 2 ton machines. What happened? It enables to lift the 2 ton, even the maximum capacity of the truck it was given us to 2. What might be the wrong with that system? You think and you tell me, and some different some other occasion you tell me what was the issue, and why it doesn't lifted the 2 tons. Even it can have the capacity of 2 ton. And the power trucks to pull one or more trail carts in factories and warehouses, as well as for airport baggage handling and all, we are using the power trucks. And AGVs, see, there are some examples of AGVs, that is driverless trains, pallet trucks, unit load AGVs. And it was introduced during 1954s, now to handle the various things. See here, various accessories or nomenclature related to the AGs: bumper, drive wheels, platform, human operator, and pallet, fork and pallet. And unit load carrier has the driver wheels and roller disc for side loading. And AGV applications are driverless train operations, and storage and distribution, assembly line operation, and flexible manufacturing system. And see, the rail guided vehicles, it has the motorized vehicle. In I beams, it is usually run. It runs over the I beams. Vehicle electrical pickup. See here, the electrified rails, in order to handle very huge weights. In industries, we are preferring this overhead monorails. And conveyor systems, these also classified into non-powered and powered. And it can be the types of conveyors are roller, scat wheel, belt conveyors, inflow tow lines, and overhead trolley conveyors. And see, roller conveyors, and stack wheel, and belt conveyor. And usually we have some rollers in between these two pulleys. Here they were given as roles: drive roll and idler roll. These are all the driving pulley and idler pulley. We have some roller in between these two main drive system, that might be called as an idlers. in an ideal way it rotates, but it tries to maintain the position of the belt as it was. And see here, support slide. Instead of support sliders, we have idlers in some middle landing system. We are transferring the huge materials like in rice industries, in sugar cane industries, in cement factories and all. We are using belt conveyors, and in floor tow line and overhead trolleys and all. We are using in order to handle the material from one place to another place. And see cranes, hosts, and some examples of first and bridge cranes, canopy crane, and jib cranes. And that's all about the robot applications. And we were discussed various robot applications today. In detail, we were discussed the metal handling, metal transfer and load, and the various applications of these metal handling system. And that's all about today's session. And do you want to discuss anything? Any clarifications?
So, like, there was one question in the assignment where, like, they asked what are the drive methods for this. What are the drive methods for robotic systems? So, like, the answer will be pneumatic drive, electric drive, and all of that only.
Yes. Tell me the number of questions. Serial number.
So wait, serial number. I'll have to search. Yes, sir. Can you like go up? Yes, sir. 29. 29.
29.
Yes, sir.
Explain briefly various drive methods and used for robot, because see this is 5 mark. You give the types in detailed one or
So
two.
like types are that pneumatic, electric, and all that only, no?
Yes, yes, yes. Wait, just a minute.
Yes,
I'll
sir.
tell you briefly.
Yes.
Okay. Anyway, I'll complete it through WhatsApp. Any other queries?
Yes, sir. Question number 30 also I had some doubt. I
What?
so like I couldn't understand what will we write in the first part, like translational gripper using cylindrical piston. I couldn't understand. So parallel bar linkage I could do, but cylindrical piston is confusing, sir. What will we write?
Okay. Okay. Then.
Sir, only this much.
Okay. Any other?
No, sir.
See, in connection with this, the 30th question, the cylindrical piston parallel ball linkage, there are some figures are available to make a description over the two methods. You draw that diagram and you please explain about that translation gripper.
So like which diagram is it there in the PPT?
That is not available in the PPT suddenly.
Okay,
You
sir.
refer Rajgut. In the
Okay,
Rajgut
sir.
itself, you can find these questions from many of these questions are from Rajgut. In the question and answer sections, you can find the answer also.
Okay, sir. Thank you.
You can find. I think very minimal pages is also only I have uploaded around 200 pages from Rajgut. With that itself, you can find these answers.
Yes, sir. Thank you.
In connection with the 29th question, you need to explain about the pneumatic drive, hydraulic drive, and electrical drive. Okay, any
Yes,
other?
sir.
Sir, for question number 1 and 2, sir.
1 and 2.
1 and 2.
Okay.
Sir, we just check the definition. I don't think it will be enough for 2 marks.
Okay, you add something.
Sir, what shall we add, sir? You can add anything, sir.
Anything, under the head, under the forward kinematics, you add.